Hi guys, welcome to another episode of MrLopezClasses.com. This is our marine auxiliary systems. We are going to continue with the hydraulic chapter. This is the chapter 2 and this is the episode number 4. This is a special episode because we are going to study the procedure to integrate all the hydraulic system in a boat in one hydraulic central unit. And I divided the episode in two sections. In the first section, we are going to visit the laboratory and we are going to check in a bore, in a hydraulic bore, the procedure to connect those auxiliary systems integrated in one central unit with one pump, with one reservoir, one motor, with the capacity to support the rest of the systems. And this is an especially of this is like an schematic, and we are going to connect with plug and play hoses each system. This is a wonderful laboratory. The stand is a hydraulic stand, professionally designed in order to integrate systems. And after that, we are going to visit a couple of boats. And we are going to see that integration in the real life and how the pumps, the electric pumps, AC and or DC, and the PTOs work together, and how those systems are integrated. We are going to visit an azimuth 85 feet. That azimuth boat has a surface drive system, and the surface drive system is also integrated with the system. Wonderful scenario. And the second one is a big mega yacht, 120 feet. In that boat, we are going to check all the hydraulic systems integrated in one central unit, and the PTOs located in each transmission, the transmission of each engine. This is a wonderful episode. I want that you enjoy the episode, and I want that you learn the procedure to administrate those systems in the future. We are going to start right now with the lab, with the stand, the hydraulic stand that we have in the lab, and we are going to check the procedure to connect system by system integrated in one. As I mentioned before, in a typical boat, medium boat, big boat, mega yachts, we have a different type of hydraulic systems, but all of them have a less common denominator. For example, we have the typical trim tabs with flaps like this, or we have the typical power steering system with a power assisted unit like this, or we have the typical trims in the inboard outboard or steam drive system, the trims for that system. The trim system for inboard outboard or steam drive system is basically an electro-hydraulic unit connected with hydraulic rams, and those rams trim the lower unit up and down. How? With the switch up and down on the console. With that switch, activate the hydraulic pump and the actuators goes up and down. Right now, we are going to understand how this system works. Once again, this electro-hydraulic system is exactly the same like the rest of electro-hydraulic system. We have an electric motor in this particular case. This is a reversible motor, DC motor, 12 volts or 24 volts. If the power enters through the green cable, rotate clockwise. If the power enters through the blue cable, rotate counterclock. How? With a couple of relays connected in the similar way that I explained in my electrical class. It's too simple because I have the green signal coming from one side of the switch to activate the green power, and I have the blue signal to activate the blue power. And
the big power coming from the battery enter in the middle of both relays. This is the situation. I have the main power entering in the middle of both relays, and I have signal for one direction with the blue one extend, and with the green return. And this is possible because the reversible motor turns in one direction or other direction. There are a lot of hydraulic systems, for example, the actuators to open and close the garage door or the pasarela can be activated for a hydraulic system like this. The activation is a dual function. With the AC power, it's a 3-phase 400 volts AC, that's the normal operation with power from the shore power or generators, or a DC 24 volts DC in emergency. You can operate the garage door in both scenarios with AC power or DC power. Right? This is the button to open the door, close the door, to lock the door and lock the door. It's a simple way to do the process. All of those hydraulic systems have the less common denominator. In this board, I have an integration of all of them. Let me explain something. I can integrate in a boat all the hydraulic systems in one unit. That unit is a central hydraulic unit, like this. This is a typical central hydraulic unit. The reservoir, the body valves with the servo solenoids. Look, this is a body of valves, two positions. The central position is neutral, position for up, position for down, and this one in particular is controlled for a couple of solenoids. The solenoid receives the signal from the control, the push button on top is for a windlass, or from the control in the console. You have one servo valve for one element, probably bow thruster. You have another one servo valve for the garage door, and this motor is an AC motor. This is an AC motor. The other one that we have in the back is with a DC motor. If you check the solenoid and the DC motor, and once again you have the motor, reversible motor, and you have the reservoir, the container for the oil. That central hydraulic unit can concentrate all of the hydraulic system in one. With only one motor, the solenoid control valves, each solenoid control valves per each equipment, and the reservoir in the bottom. This is a perfect example. The motor in that case could be AC or DC. And you can administrate all the hydraulic systems in one central unit. In this particular example today, we have a perfect example of integration. Let me explain this particular board, how the board works. In this particular board, we have exactly the same. We have the reservoir over there, we have the oil filter, the pump, and the motor, the pump, the filter, and the reservoir. Of course, the motor, the pump, send the fluid for the discharge manifold, supply manifold or discharge manifold, and the return enter in this manifold. In other words, this system is pretty similar to a typical electrical system. The supply manifold will be the positive bus bar in the electrical system, you remember? And the return manifold is the negative bus bar. Remember, the negative bus bar should be connected with the main negative bus bar and connected with the bonding system. Exactly the same like this. Okay, and now I can integrate the system completely. What is the procedure to do that integration? The procedure is like this. I am going to integrate the hydraulic system of the pasarela with the hydraulic system of the garage door, the hydraulic system of the bow thrusters, the hydraulic system of the steering system, all the hydraulic system integrated. What is the secret in that integration? oh, I need know how much PSI require each system and how many gallons per hour or gallons per minute require each system. Why? Because I am going to calculate, I am going to size the capacity of the electric motor and the capacity of the pump. The capacity of the electric motor in kilowatts and the capacity of the pump in gallons per hour, in order to calculate how much pressure I need in total in the supply manifold. And now I can integrate all of them in one unit. Suppose that at the end of the exercise, I need in total, in the case that I have all the equipments working at the same time, that's not possible, but we are going to calculate supposing that all the equipments are working at the same time. Suppose that everything together is 800 psi. 800 psi. Okay, for safety I need a little higher. I am going to design my system that supply in total 1000 psi. And additionally, I am going to add the gallons per hour of each system. And I added all of them. With the total amount of gallons per hour and the total amount of PSI, I select in my catalog of pumps the pump required. With the pressure and the gallons, I can calculate the total capacity of the motor in kilowatts with this formula. With that formula, because I know the pressure and I know the total amount of gallons per hour, I can calculate the capacity of the motor. And bingo, right now I have the electric motor and I have the pump. And I am ready to connect all of my equipments in my boat together in a common positive or supply manifold and in a common return manifold. And this is the situation. In this particular case, I have my motor with the capacity in order to supply 1000 psi and the pump enough to supply 1000 psi. And right now I am ready to connect different equipments. For example, here I have my bow thruster. This is the motor. This is a hydraulic motor. Right now I can replace my previous electric bow thruster for a hydraulic bow thruster. And now I can connect here the actuator for the pasarela. And I can connect here the actuator for the garage door. In other words, I can integrate all the equipments, hydraulic equipments of my boat in one central unit. Once again, the secret is calculate the motor in kilowatts. Remember, if the motor is double phase or three phase, require less amps. And also, I need calculate the capacity of the pump in gallons per hour. Perfect. And now, I am going to connect in this way. That's the pump suction the oil from the tank, from the reservoir, and the pump it with high pressure the fluid into the supply manifold. Because this is the high pressure line, I have a pressure regulator over there. That pressure regulator is used to keep the pressure constant in the supply manifold. Okay, right now I have pressure here in the supply manifold. And now I can connect different equipments. In this particular board, I have those sequential valves. Those are the body of valves. This is the input of the fluid and this is the return of the fluid. And those are the sequential valves. Right now I am going to connect this one. Depending on the equipment, I have here 1000 psi. But this equipment only need 150 psi. And this equipment only 200. And this one only 250. Per each of those elements, I can use a pressure regulator. Like this. This is a pressure regulator. The input is 1000 and the output is 300 psi. Input and output. This is a pressure regulator. This is another pressure regulator for 400. This is another pressure regulator for 500. I can use different pressure regulators according with the pressure that I need in each equipment. I am going to connect all of those elements in a simple way, and I hope that you enjoy this schematic, because you can reply this schematic in your boat and you can connect everything together. You can simulate that situation in a big scale in your boat. Okay, I have the supply manifold. The supply manifold can be connected directly. This is a red, yellow. I connect in the sequential valves at the input, and the return is connected. The return is connected with the return manifold. And right now, I have two options, two sequential valves. One sequential valve, I am going to use one of these for my bow thruster, and I am going to use the other one for the garage door. Okay, let me explain the procedure to connect those sequential valves. I prepare hoses with the same color in both sides. This is black with yellow, black with yellow. All right, I am going to connect one of these in the bottom with one valve, and the other end for this actuator, and the other one yellow will be connected here at the other end of the actuator. And right now, it's supposed that the actuator is running. Let me start. I start the pump, and now the actuator up, down, lock, down, up, and down. Okay. Right now, the garage door is connected. Okay, I am going to connect the bow thruster. For the bow thruster, I have the same situation. For the bow thruster, I prepare a couple of hoses. One hose in the second valve. Quick connectors. Probably in your boat, you need to install permanent connectors. And the other end here. And other hose for the other end. And right now, I can operate the garage door and the bow thruster at the same time with this unit. The motor, bow thruster, one direction, other direction, with this valve, and the second valve for the actuator. But in this moment, I don't have gauge. I want to connect the gauge. You remember in electricity, when we connect the amp meter and the voltmeter, it's exactly the same. What do you think is the equivalent in hydraulic system to the amp meter? Yes, the amp meter is equivalent to the flow meter. The flow meter in gallons per hour or gallons per minute. Yes, I have a flow meter here. Look, it's in liters per minute or gallons per minute. Gallons per minute in the bottom scale, and on top, liters per minute. Okay, and now what is the procedure? What is the procedure to connect the flow meter? I can connect the flow meter per each element in order to calculate how much is the consumption in gallons per minute of each equipment. Or I can connect the flow meter for all the system. I am going to connect for all the system. In other words, this is the supply manifold, and this is the line that enter into the sequence valves. I am going to disconnect this one here, and I am going to enter in the flow meter. And now from the output of the flow meter, I am going to enter in the body of valves. I am going to connect other line over there. This is the second line that I am going to connect here. One line from here into here. And now I am going to start the system, and I am going to calculate the pressure when the system is working together, both of them, and the consumption in gallons per minute. Only for the bow thruster. 400 psi and 3-4 gallons per minute. That's the bow thruster. Bow thruster with garage door at the same time. And now I have my ammeter or flow meter connected in series with the system. And the pressure gauge is the voltmeter. My friend, this is the simple way to integrate every. Oh, I can connect more equipments because in my supply manifold I have more options. For example, I need connect the other actuator. I need connect lines. One supply line here, the return over there, and both of them into the second cylinder. And that's it. I have other valve for the other equipment. This is the procedure to integrate different equipments in a central hydraulic unit. You can do the replica in your boat in order to integrate everything in one central unit.
Okay guys, you enjoy the video? You enjoy the explanation? Yes, it's possible. You can integrate different hydraulic systems in a central hydraulic unit. It's not complicated. I am going to refresh the calculations and the procedure. Probably in the future you don't need calculate because probably you founded those central hydraulic units prepared, ready for your boat. But you understand what happened. You understand what is the procedure to size those hydraulic central units. You understand in the future why it's not possible added and other extra equipment, because the capacity of the electric motor and the capacity of the pump is not enough for the new equipment that you want to add it. But it's not complicated. Let me refresh quickly. Those are the formulas. Those are the formulas that we are going to. Don't forget, flow, exactly the same like in electricity. In electricity, the flow is in amps per hour, you remember? Okay, in hydraulic system, the flow is in cubic meters per second. This is one unit. Other unit is gallons per minute. Other unit is gallons per hour. You can convert one into the other one with different converters that you found in internet, right? This is the flow, gallons per minute, gallons per hour. Those are the most common. Flow. All right, how I read the flow, you remember in the video? With the flow meter. And the flow meter is connected in series. You interrupt the supply line, the positive line, and you insert in series the flow meter. Yes, there are flow meters mechanicals, there are flow meters electronics, and you can with the flow meters electronics you can install in the fly bridge, in the pilot helm, and other display to check the consumption, the flow of your system. Okay, this is the formula for the flow. The second formula is the most important, is to calculate the horsepower of the pump. The horsepower of the fluid, the horsepower of the pump is equal to the pressure of the pump in psi times the flow of the pump in gallons per minute and divided by 1714. This is a formula that I want that you keep in your mind. It's a very important formula. The horsepower of the pump, the horsepower of the fluid is equal to the pressure of the fluid in psi times the the flow of the pump in gallons per minute and divided by 1714. Alright? Don't forget, this is an important formula to calculate the horsepower. And now with the horsepower, this is the horsepower of the pump. Oh, but I need to know how much is the capacity of the motor in watts or kilowatts. Simple. You remember some years ago in our electrical classes, the magic formula to convert mechanical horsepower into electrical power. The formula said 1 horsepower is equivalent to 746 watts. 1 horsepower is equivalent to 746 watts. Okay, with the horsepower that you calculate over there, with that formula, you can calculate the watts or kilowatts required in your motor. And this is another important selection. In the electric motor, remember, if the electric motor that you select is single phase, you need a big motor with too much capacity in amps. Oh, if you select a motor double phase, probably need half amount of amps per hour. Or if you select a three-phase motor, less. For that reason, it's important verify the power that you have, the electric power that you have in your boat is single phase, is double phase, is three phase, and according with that, you select the electric motor appropriate. Okay, my friend. And this is the formula. Okay, with that information, you can use that wonderful table. In this table, if you have the gallons per minute here, and if you have the pressure, you can calculate the horsepower on this table. Yes, my friends, you have the pressure on top, you have the gallons in this column, and you calculate the capacity, the horsepower of the pump. Bingo, you don't need more. This is a wonderful table. Try to keep that table, printed that table if it's possible. Okay, I am going to post that table in my web page. Okay, and other important rule. This is a wonderful rule. You need 1 horsepower per each gallon per minute at 1500 psi of pressure. You need 1 horsepower per each gallon per minute. This is good rule. And look at the example. The example said at a 5 gallons per minute pump operating at a 1500 psi require 5 horsepower. Of course, don't forget, you need 1 horsepower per each 1 gallons per minute at 1500 psi of pressure. This is the rule. If you don't have the table with that rule, you can be approximated to the capacity of the pump that you needed. My friend, I hope you enjoyed that video. That explanation is clear, is simple. And now we are going to visit a couple of boats, and we are going to check how was the integration on those boats. Let me explain something before we visit those boats. The servo valves, the solenoid valves. Remember, in the previous video, the sequential valves are activated manually with my hands. You remember that one? Up and down is activated with the handle. Those sequential valves are manuals, mechanical sequential valves. But in some cases, those sequential valves are with solenoids in both sides, like this one, you remember? And those solenoids receive the signal from the push buttons or from the joystick. Those. In other words, the sequential valve can be activated manually or with solenoids. The pump in the previous example is driven by an electric motor, AC or DC. In some cases, that pump could be connected directly in the output of the crankshaft of any engine, any main engine, or that pump should be connected in the transmission. The input shaft of the transmission have a gear, and the gears are connected with the gears of the transmission. When the pump is connected to the transmission or to the crankshaft of the engine, that pump is called PTO. And those pumps supply hydraulic fluid at high pressure, of course, when the engines are running or when the generators are running, if the pump is connected to the crankshaft of the generator. Okay, the PTO is a hydraulic mechanic pump. It's a hydraulic pump connected gear with the motor or with the transmission of an engine. This is the PTO, and supply hydraulic fluid for all the system centralized in the central hydraulic unit. Okay, but in that case you need that the motor be running all the time. No, I don't like that, because what happens when I stop the engine? Okay, when you stop the engine, you can create an other backup with electric motor, AC or DC, to operate the pumps and produce the hydraulic power in the system. Yes, the majority of the big boats, they have both of them. They have the PTO connected to the transmission of the engine, and when the engine is off, the electric motor, AC or DC, supply the power for the system. And this is the situation that we are going to check right now in the first boat. And after that, we are going to check exactly the same situation in other mega yacht. Okay, in the first boat, we are going to start checking. This is a perfect boat. It's an azimuth, 85 feet. In this boat, all the hydraulic systems, flaps, passarelas, garage doors are integrated, and additionally, the propulsion system of that boat is a surface drive, you remember? And the surface drive, the actuators of the surface drive for steering and trims are connected to the central hydraulic unit. And in that moment, Stephen Martin is repairing the system because the system have leaks on the cylinders. And remember, those cylinders, those actuators are submerged in the salt water, and the water enter and penetrate into the oil, and the oil is a milky oil in this moment. Okay, this is a great example. We are going to check the video with Stephen Martin in the azimuth 85.
Today we are with Stephen Martin, the owner of a big hydraulic company dedicated to marine services, hydraulic services. Martin, how are you?
I'm good today, thank you.
Thank you very much for this interview. Today we are in front of a surface drive system.
Yeah. This is an ASD 15.
AAC 50. Is too much pressure on those rams?
The max operating pressure that these can take, these cylinders, is about 5,000 to 6,000 psi. The operating pressure is between 1,200 and 2,200 or 2,200 psi, depending on
each
the demand.
In this particular case, this ram is for trim, but you have the other rams for steering,
yes.
No? Those rams use 1,000 psi around?
Those use, the operating pressure is the same as this. They operate between 1,200 and 2,200 psi. The max operating pressure is about 6,000 psi.
Those cylinders receive internally the pressure and the flow from the central hydraulic unit.
Yes, sir.
And the central hydraulic unit in a typical boat like this, how long is it, that boat?
This is 80 feet.
80 feet. In a typical boat like this, in the central hydraulic unit, what type of systems are integrated?
Everything is integrated into the central hydraulic unit. So your flaps,
the flaps,
see, we're rebuilding the flaps now.
The flaps for the trims, yeah?
Yep, for the flaps. The trims here, the steering, the gangway,
the
ladder above you,
the ladder,
the doors,
the davit,
the doors, anything hydraulic on the boat, the central hydraulic unit will pressurize and work as needed.
Correct. In other words, if I use 2 or 3 systems at the same time, for example, the flaps, the trim, the passarella, in one moment I need 3,000 psi, 4,000 psi.
We can do it.
And the system is able to supply that power.
Yes, sir.
Oh, nice, wonderful, no?
Absolutely.
That's wonderful.
Absolutely.
And what is the secret in the service on those units?
Yearly, you have to change the fluid, change the filters, send out the fluids for analysis, make sure that there's no compromisation between metals breaking down, contamination with water, because on a normal hydraulic unit, you're using it outside the water, you're not using it in the water. This situation, we're using it in the water. So if the seal goes bad,
Yeah, the seals are immediately you have a leak.
you have a leak, so then the water goes into the system. The good thing is if you have a little leak, it'll stay in one area. If you have a big leak, then it'll go through the whole entire
Correct,
system.
correct. Oh, that. And you send the oil sample to the same laboratory used for the oil sample of engines and generators?
Yeah,
It's the same. No?
Same. There's
Okay.
no difference. There's no, if you don't have to go to a hydraulic specialist, you can
No.
go anywhere to do it.
Nice. And with the report, you can take a decision. Oh, the problems are on the seals, on the rings.
I can narrow down the problem all the way to the washers being bad
Yeah,
inside.
correct,
The springs,
correct.
the washers, the ball, depending on the chemical compromisation of the drives, because every material has a certain chemical compound in it. So the nitrile has a certain chemical. The aluminum has a certain chemical. So the
Each one.
analysis will say, okay, you have 200 parts per million of aluminum. So I know, okay, well, the housing is aluminum. Or it'll say you have 200 parts per million of brass. Okay, well, then the spring is brass, so I know the spring is going bad. Or it'll say you have 200 parts per million of chromate in there.
Correct,
So
correct.
then the chrome, I know, okay, is the little ball bearing that's
Of
inside.
course.
So I can narrow down by the analysis what the problem in each area is.
Steven, how often you recommend flush the oil in those systems?
The drives we do once a year.
Once a year?
The hydraulic system, depending on the operating hours, it could be once a year, it could be every other year, it could be once every 3 years.
Depend on the manufacturer of each system.
Each system has their own requirements with what they require for maintenance and service and whatnot.
In general terms, each manufacturer have your own recommended oil. When you integrate different systems in a central hydraulic unit, you use a unique oil?
Yeah, well, certain systems need different oils. So let's say if we have 3 different operating systems, we'll have 3 different oils on them.
Correct. Oh, yeah, I understand. It's possible that if one of those systems integrated in a central hydraulic unit are broken, I decide install that system independent with another hydraulic unit? Yes.
Absolutely.
No problem, no?
We can separate everything. We can make this run independent. We can make anything run independent.
Yeah, but it's excellent when you have everything together in the central hydraulic unit.
Absolutely.
Okay, right now we are going to check inside with Steven the central hydraulic unit. Steven, other important element in a central hydraulic unit is the pump.
Yep.
There are 2 ways. If I have the motor integrated with the reservoir, electric motor, AC or DC, or if we have a mechanical hydraulic pump like this.
Yes.
This one is at the end of the transmission. How is the connection of that PTO?
Okay, so this PTO pump connects through the transmission. So when the transmission's spinning, when the flywheel's spinning on the engine,
Correct.
when the engine is on, it's constantly spinning. So when that's spinning, it spins the transmission and it makes the PTO pump run. So when you ask for demand, the pump turns on. So
Correct.
this is called the Casapa pump. This
Oh.
Casapa pump works on demand. So it can either, when you request it, it goes into an idle mode when you're not requesting it.
Oh, yeah.
So
yeah.
when you're not requesting, like if you're not steering the boat,
Correct.
then it goes into an idle mode. If you're not operating the trims, it goes into an idle mode. So it only pushes pressure when you request the pressure. Okay, so
It's an on-demand pump.
it's an under, yes, exactly
It's an
right.
on-demand.
So on this engine in particular, we can run with either engine on. Okay, so we can run with the port motor on or the starboard motor on. Both motors don't need to be on. But once the engine is on, this takes over for the electric motor. So the electric motor disengages and it just runs on a PTO pump.
When the PTO pump is running because the engine is running, the electric motor in the central hydraulic unit is disconnected.
It disengages. The only thing we use is the oil out of the tank.
Correct.
That's it.
Only use the reservoir of
That's
the
it.
central hydraulic unit.
That's
a
it.
wonderful design. How is that process to disengage the electrical motor from the mechanical?
So as soon as it switches on, the computer tells it, hey, my engine is on. I'm requesting power from the PTO. There's a centralized computer system that tells you, hey, engine on, electric motor off.
or vice versa.
or vice versa. So when the engine shuts off, it's not sending the signal,
Correct.
and then the signal shuts off. So it's like a handshake. It's sending a repeating message back and forth.
Correct.
So however milliseconds it takes to get up,
Uh-huh.
it basically shakes or it doesn't. So then if it doesn't do that, I'm using this as an example. It's not exactly how it works.
Yeah, I know.
But that's roughly how it works. It
Okay.
almost works like a handshake. So it's sending the signal back and forth. So as soon as it doesn't receive the signal here, it takes over for the electric motor.
Oh, wonderful. And I suppose that this system is integrated with the NMEA backbone, and you can administrate everything in the main screen.
On the newer systems, yes. On this older system, no.
No.
Because
Oh.
this is an older system. On the
It's
newer,
independent.
on the this is an independent system. So the newer systems, yes.
Yes.
There's a constant communication going back and forth, and it's all backed by a CAN bus wire.
Oh,
So it's sending a signal.
Correct. Sending the signal.
Here we're working off an antiquated
yeah,
system,
yeah.
so it's a little bit different.
Oh, wonderful. That's magic, no?
Yeah.
Every day is more integrated and more integrated, no?
Yeah. Well, now we just push a button. That's it.
Yeah.
Now it's just we make it so you don't have to guess. It all comes on one computer screen. You just push a button and go.
Steven, in some cases the PTO is in one of the generators, not on the main engines, no?
On some cases, on our situations for our applications, all our PTO pumps are going to be either on
the main
engine,
engines, okay.
on the engine, or on the gear itself.
Oh yeah, correct.
Because it works off the flywheel. On bigger boats, like on traveling boats, bigger yachts, they have specific generators that just operate the hydraulics.
Correct. But yeah, that depends on the design, no?
Depends on the design.
Depends on the design. In other words, the hydraulic system can be integrated in any type of boat.
Any kind of boat.
It's wonderful, no?
Any kind of boat.
And you integrate different manufacturers in each solution?
Yep. We can integrate 5 different manufacturers if we needed to make whatever we needed to happen.
I think that the hydraulic system with the electronics is the future of the boat, no?
The world moves by hydraulics.
Yeah. Because
Simple.
you multiply the force and the torque hundreds of times, no?
Yeah.
It's incredible.
We move airplanes by hydraulics.
Yeah.
We move plants by hydraulics. We move farm trucks by hydraulics.
It's incredible.
Hydraulics.
The travel lift. The travel lift
Hydraulics.
is a hydraulic equipment.
It's all hydraulics. We move water by hydraulic.
Yeah,
When we
correct.
pump water from water management districts and we move water, it's all by hydraulics.
Yeah, incredible.
All hydraulics, not electric.
Steven, in this particular case, we have the reservoir. We have different servo valves with a solenoid, 1 servo valve, 2 servo valves, 3, 4, 5, 6. I suppose that each servo valve administrates one system, no?
Yes, sir.
Correct.
It's an in and an out or an up and a down.
Okay, perfect. And depend which solenoid is activated. The system goes up and down or left, right.
When you ask for a command, it sends electricity to the solenoid.
Correct.
It opens the valve and it sends the fluid one direction or the
Yeah,
other.
for example, suppose that this one is for the anchor, and when I activate down, this solenoid activate the position. When I activate the up, is this solenoid activated on the switch on the console?
Correct, 100%. And
Correct.
then your flow valve is right underneath.
Correct, exactly.
Their flow valves are right underneath. So if you're getting chattering, or if it's moving up too quickly, or if it's moving down too quickly, then it will you can adjust the flow rate right there.
You can adjust the flow in gallons per minute here with this valve.
Yes, sir.
Perfect. And what about this, Steven?
That's our emergency valve. So if we lost our electric motor, we would be able to pump that pump.
I can change the position of the servo valve with my hand.
Yes.
Oh, wonderful.
Absolutely.
In case that, for example, the pasarela is extended and not retract,
Exactly.
you go here and you retract.
Exactly right.
And now we are going to visit another wonderful boat, 120 feet long, and we are going to check different hydraulic system integrated in the central hydraulic unit. First of all, we are going to check in the engine room where are located the PTOs and how those PTOs are connected with the central hydraulic unit. Those are the PTOs.
In this boat, we are going to analyze where are located the PTOs and where is located the hydraulic central unit. This boat uses a V-drive transmission. Both engines V-drive transmission. Those are the V-drive transmission. That's the V. And the PTO the PTO is integrated with the transmission. The gears are connected with the transmission. This boat have two PTOs. One PTO in each main engine. In the starboard engine, a starboard PTO drain power, and this one is the PTO for the port side. Both PTO. Those are the hydraulic, the central hydraulic pumps.
And now we are going to check an backup unit used for the bow thruster and the windlass in front of the boat, in the bow of the boat. And that unit have the reservoir and the body of valves with the servo controls exclusive separated for those units.
This is another great example of a central hydraulic unit. The pump is coming from the PTO or from the electric motor, AC motor. And this is the body of valves with the servo solenoid. We have a couple of servo solenoids for bow thrusters. And we have another body valve with servo solenoid for the windlass. In this particular case, this valve body integrates bow thrusters and windlass. And the solenoid for the bow thruster receives the signal from the joystick, left side and right side, steam thruster, left side, right side, and windlass. And windlass with two solenoids, one for up and other one for down. This is another great example of bow thrusters and windlass integrated in a central hydraulic unit.
And now we are going to check an additional central hydraulic unit only for the steering system, and the autopilot. And that unit is located in the transom, in the lazarette of the boat. It's difficult to access, but the unit is in perfect conditions. It's the reservoir, the pump, the body of valves, and the solenoids.
This is the auxiliary hydraulic central unit for the power steering in this boat. As you can see in the bottom, we have the reservoir, the body of valves with the servo solenoids, and the motor is an AC motor. This is a perfect central hydraulic unit. You can see the level of the oil over there. That's the reservoir. This is the body of valves, and those are the solenoid valves, the servo solenoids for the power steering.